Hi guys, so since we are talking about the packet switching, I think it's worthwhile to see this small simulation, and through this simulation we will just try and see how the client is able to make a request to the server, and you can see the packet traveling from the server and a response coming back. But that's not just about it. Actually, I want you to see the structure of the packet at each layer. That's the main aim. So let me go to the simulation mode out here, and I want to actually examine the HTTP packet. So okay, that's set, and then I am actually going to go to the web client, and here I will just try and contact the web server. So let me go to the desktop and the web browser for the client. It's a bit slow, but okay, so here is the web client. I think I already have osi.local. That's the server's this thing, and I go right. And now if I just click on the simulation, you should see a web sort of a packet emerging. And when I go ahead with my simulation, you will see it going ahead and then getting a response from the server. So that's happening because they are both on the right now on the same network. So it's sort of a point-to-point connection. Now what I want you to see basically is the event list. Okay, it just shows the events that have happened so far. So packet going from client and then a response coming back. And now I want to inspect start from the first event, which is the HTTP event. So if I go here and click on it, this is what I get. Got minimized. Okay. It's a bit laggy, but all right, sorry about that. So here is what I want you to see and understand. If you see when the data packet emerged, if you see the contents of layer 1 or events of layer 1, it says the first thing that happened at layer 7, which is the topmost layer of the network stack, which is the application layer. Okay, we are using a web browser to make an HTTP request. So what happened here at the application layer is the HTTP client sends a HTTP request to the server. Okay, now when the packet moved down, okay, what happens is at layer 4, which is the transport layer, our TCP protocol is in action here. Okay, what TCP basically does is it inspects the data packet and it adds some information to the original packet. Okay, so at layer 4, what TCP has done, it has added some information about the sequence number of that packet. Okay, what basically happens in packet switching is that the original message is broken down into several data packets. Okay, so in order to get it reassembled in the right order, we need something called a sequence number. Okay, that this packet is on the 5th number or the 6th number, depending upon how many pieces were made of that original message. Okay, acknowledgement number, the data length, how much is the length of the data which is in this packet. So all of this information is handled and added to the original data packet by TCP at layer number 4, which is the transport layer. Right, when I move down my packet to layer number 3, IP or internet protocol is in action here. Okay, and it will also add its own information to the packet which is coming from the top. Okay, so what is IP going to do? IP is going to actually add the source and the destination IP addresses to the data packet so that it can reach the desired destination. Okay, so you can see the packet is moving from top to bottom, and each of these layers and the protocols which are working on these layers are adding their own bit of information, right? When you reach layer number 2, which is the Ethernet layer, or we sometimes also call it data link layer, this is where the physical MAC addresses come into picture. Okay, so at the Ethernet layer, let's see what's happening. So when the web client sends a request, the next hop is the unicast. Unicast means it's a point-to-point connection basically. In this case, it is unicast, of course, because it's just a point-to-point connection between client and server. So next thing says, it says that the ARP process looks it up in the ARP table. Okay, now this is something which might be new for you. I just want you to refresh your memory, just go back in time when we were first time discussing about routers. I told you that a router is an intelligent device because every router has a routing table. Okay, sort of a table which has the next hop's IP address in its table. Okay, so every router knows which router it is attached to, and it chooses the shortest path for the data packet. Okay, that all happens in layer number 3 because router is a layer number 3 device. Okay, but layer number 2, at this layer, what we need to do is we need to somehow translate these IP addresses into physical MAC addresses of the device, which is the destination. Okay, so that process is done by another protocol which is called the ARP, or it's a address resolution protocol. It just looks up the source and the destination IP addresses in the ARP table, and it translates them into the actual physical MAC addresses. That's the job of ARP. Okay, and that happens at the layer number 2 because layer number 2 is the Ethernet layer. Okay, so this is what is happening. So next hop IP address is in the ARP table. It finds out that this source and the destination address is actually in its ARP table, and it can actually easily translate it into MAC address. That is what it does, because it finds the MAC address of the server looking at the IP address of it. Okay, then the device encapsulates the PDU into an Ethernet frame. PDU here is nothing but protocol data unit. It's just another way of saying data packet or data unit, just a technical term, which Ethernet calls it. Okay, so you see the data is flowing from top to bottom, and every layer and every protocol is doing its work and they are adding information to it. Okay, I can just show you the structures also. If you click on outbound PDU details, which means the packet which went out, okay, from the client to the server, if I want to see the details of it, so here, and I know it looks complicated, but very easily you can see this. Okay, let me just increase the size of it somehow. Okay, here, so the bottommost is the HTTP request, which was the original request, and then when the request reached the TCP level, which is this data packet here, it adds the source port and destination port, which is of course 80 since it's a web server. It adds the sequence number and acknowledgement number to the data packet. Okay, then it passes it on to layer number 3, which is the IP layer, as I explained. An IP layer is going to add its own information to it. You can see that it adds the source IP address, it adds the destination IP address, it also adds the TTL, which we've already discussed, it's time to live. Okay, so 128 hops is the maximum for this data packet, after which it will be discarded so that it doesn't get into an infinite loop and keeps traveling on the network without reaching its destination. And finally, from the IP, it reaches the Ethernet layer, which is layer number 2. And over here, what happens? The ARP comes into action, and it looks up the destination IP in its ARP table, and it translates that into a destination address, which is a physical MAC address of the server machine. Okay, so this is what happens in packet switching. Every single packet has to go through this entire process. Okay, sometimes when we the entire aim of explaining this to you is to explain you that encapsulation of the data is happening at each layer. Okay, it's not just one data packet, but it has to pass on each of the network layers, okay, over the network, and each layer is doing its own job. Okay, sometimes when we explain this concept to the students, we even compare it to those Chinese dolls. Have you heard about those Chinese dolls? It's like a small little, this one I'll just show you. It's called the Matryoshka dolls. Okay, it's just a comparison that we sometimes make. It's just interesting to see and compare it with real life. I don't know, it's very slow right now. This kind of a doll I'm talking about, it's just the, dolls inside each doll. So it's just like, if you look at these dolls, these are very, very popular in China. And this is like the HTTP request, layer 7, which will add some data and pass it on to TCP, which will add its own data, pass it on to IP, and IP will add its own data and pass it on to Ethernet. And finally, the data which is in a physical device is this bigger data, which is in the form of just bits. That's the physical layer. Okay, that's the 5-layer model. Okay, that's about it. Thank you.